Hi everyone, today I'm going to talk about a project we did to analyze the queuing system at a popular drink shop, Mixue, Pasir Puteh. So, what is a queuing system? Simply put, it is the process of customer arriving, waiting in a line, getting their service and then leaving. We all know that queues from when more people arrive than the staff can serve quickly. Today our study, we observed the shop for 1 hour from 10:30 a.m. to 11:30 a.m. on the 28th of June. During that hour, 30 customers arrived. This gives us an arrival rate of 30 customers per hour. An interesting thing we noticed was that even though there were 3 workers, only 1 person was actually serving as the cashier and taking order. So for our analysis, we treated this as a single server system.
Next, I will present the arrival characteristic we observed at Mixue Pasir Puteh, which have divided into 3 main parts, which is calling population, arrival pattern, and then arrival behavior. So the first one is calling population. First, the calling population is considered infinite. This means there is no fixed or maximum limit to how many customers may come to this branch. The customer that we saw come from a wide range of group, like a local resident of Pasir Puteh, student from nearby school or college, and also people just passing by through the area. And then since anyone from this whole surrounding area can visit, there is no definite number of possible customers. So we treated the calling population as unlimited. Second one is arrival pattern. So arrival pattern is a random and follow no fixed schedule. So the customer do not arrive at the set time or in a regular group. Instead of they come one by one at irregular interval, and each person arrival is independent, meaning one customer coming does not affect when the next one arrive. For example, during our observation, we sometimes saw 2 customers arrive within just 5 minutes, but at other time, no one come for as long as 10 minutes. Even through the timing change, the average number of customers arriving over time stay consistent. Number 3 is arrival behavior. So, we observe that there is no barking, reneging, and talking behavior. First, no barking. Even if there are already more than 3 people waiting in front, the customer still choose to join the queue. They do not turn away immediately just because of the line look long. Second one is no reneging. Throughout our observation period, only 1 person left the queue before being served. This is a very small number, so we can say that vast majority of the customers stay and wait until they cut their order. And the last one is no jerking. So Mixue Pasir Puteh only operates 1 single queue since there are no other line to choose from. Customer cannot switch between queue to get served faster. And so that jerking is impossible here.
Moving on now to section 2.2, waiting line characteristic. First, length of the waiting line. This is unlimited. There is no fixed limit on how many customers can queue. During peak times like mornings, evenings, weekends, or special promotions, the line can even extend from inside the outlet to the storefront. This unlimited queue line also means we don't need to account for space limits in our later calculations. Second, queue discipline. We use FIFO, or first in first out. Customers are served in the exact order they arrive. This keeps the process fair as no one gets priority over others during normal operations. Third, number of waiting line is a single line. All customers join one common queue. When any cashier becomes free, the next person in line moves forward to be served. This reduces confusion, keeps the system organized, and also avoids the unfair feeling of other lines moving faster than yours. Fourth, customer queue behavior. Customers are patient with no barking and reneging. Most people are willing to wait because Mixue offers affordable, popular drinks and dessert, while a small number may leave if the wait is extremely long. The vast majority stay until they place their order. These 4 characteristics define how the waiting line at this Mixue outlet operates and form the basis for our performance analysis next.
moving on to the configuration of the service system, let's look at how the physical service system is configured. Mixue Pasir Puteh operates on a single-channel multi-phase system. There are two parts, which is the servers and the phase. Starting with the number of servers, Mixue utilizes a single-channel model. This means there is only one dedicated order and service counter that serves all walk-in customers. There isn't a secondary parallel service LAN or a separate pickup counter. Because of this, the queue structure is strictly first in, first out or FIFO. All customers join one single waiting line, meaning there is no priority handling or line cutting. This setup is incredibly simple to manage, cost efficient, and assures an organized flow with consistent service. Now, let's look at the number of phases. Once you enter the single entry part, every customer goes through 5 sequential steps before exiting the system. First is order placement, followed by the verification payment, order preparation and waiting, and finally order pickup and handover. Much like the server setup, this multi-phase process keeps everything simple to manage, cost-efficient, highly organized, and consistent. Now, moving on to the pattern of service time. Not every customer's transaction takes the same amount of time. At Mixue, service system is random and variable. It differs for every customer based on 3 major factors. First, we have order type and complexity. Simple order make processing much faster. However, customers' requests take longer to handle, and group order requires significantly more time for confirmation. Second, the payment method plays a massive role in speed. The fastest method are e-wallet QR payments and contactless cards. Cash transactions are slower because the cashier has to count money and hand back change. On top of that, technical issues like unstable network, payment terminal errors, or price verification for add-ons can cause additional delays. Finally, there are other service factors to consider. First-time customers often need minimum explanation or recommendation, while others might ask about ongoing promotion, member discounts, or bundle deals. Time can also be added by order change, corrections, repeated confirmations, or temporary system lags.
So, Mixue Pasir Puteh fits an MM1 single server model. Field data established and arrival at 30 customer per hour, a service rate 51 customer per hour, and a single server. Our arrival rate exactly 30 customer per hour. For the service rate, the average transaction time of 70.31 customer converted to hourly capacity of 51 customer. Since lambda is less than mu, the system is stable. Server utilization is 58.82%, leaving a 41.18% probability of an empty system. This average customer count is 1.43. The average length is 0.84 customer. On average, customer spends is 0.0476 hours in the system, and wait is 0.028 hours strictly in line. We evaluate state probability using manual formula. Results show that 41.18% chance that system is empty, 24.22% chance for one customer, and 14.25% chance for 2 customers. For a large customer count, probability declines systematically. Likelihood dropped to 8.38% for 3 customers, 4.93% for 4 customers, and minimized to 2.9% for 5 customers. The summary method consolidates all the manual formula and percentage value from n equal to 0 to n equal to 5, providing the baseline to cross-reference against software outputs.
Hello everyone. Now let we move to the software application. We use a software called QM for Windows to analyze the data. The result, as you guys can see on the slide. First, look at the average server utilization. It is at 59%. This means the cashier was busy 59%, of the time, which is a healthy number. Now, let's look at the important numbers, that is the wait times. The average time a customer spends waiting in the queue is 0.03 hours, which is about 1.7 minutes. The total average time a customer spends in the system from arrival to leaving with their drink is 0.05 hours, which is about 2.9 minutes. That means that is less from 3 minutes, which is a good time to wait for your drink. Now, let's moving on to the probabilities. This table helps us understand how busy the system gets. We can see the probability of finding zero customer in the system is 41% only. This means the system is empty almost half the time, which is a good condition. But the most important thing for a manager to look at is the probability that there are more than a certain number of customers in the system. This show the risk of long lines. For example, the probability of having more than 2 customers is only 12%. The probability of having more than 4 customers is even lower, which is at 7%. And lastly, we move to this bar chart. This bar chart here visual show the same thing. You can see the highest probability are for 0, 1 and 2 customer. The chance of very long lines are very low. So what does this all mean? Based on our analysis, this queuing system at Mixue Pasir Puteh is performing very well. The wait times are short. The cashier is busy but not overwhelmed. And there is a very low chance of a long line form. Even though only one person is taking order, the system seems to be adequate for their current customer flow. That's all for me. Thank you.
In conclusion, this system is highly stable with a 58.82% utilization rate and a brief 1.68 minutes line wait time. While performance the current efficient, we recommend a secondary service lane in the future to manage peak hour smoothly.